Okay, we are going to talk about lesson 6.3, day 2 pop quiz. So it's time for a pop quiz. We hope you are ready. The game consists of 5 multiple choice questions. Each question has 4 answer choices labeled A through D. Now for the bad news. You do not get to see the questions, so you have to guess the answer for each one. Obviously, we're not going to do this, but we're going to talk about this scenario. So number 2 says, let X be the number of correct guesses. Is this a binomial setting? In this case, we need to be checking bins. So B stands for binary. There are 2 options. You either get, your success would be getting the answer right. Your failure would be getting the answer wrong. I stands for independent, which each question is independent of the next. N, you have a set number of trials where there are 5 questions, so N equals 5. And S, the probability of success is always the same because there's 4 answer choices and you're just guessing. It's 0.25. Right now, we have to calculate the probability of getting exactly 2 correct. So that would be 5, choose 2, the times the probability, which is 0.25, and you want 2 correct, times 0.75, 5 minus 2 correct. If we were to do that, that would be 0.264, and that would go right here, 0.264. If you remember this 5 choose 2, that would be 5 factorial over 2 factorial, 3 factorial. Remember, those 2 numbers have to add up to the top number. And then we could do that using each one of those for each part of this. So if I were to do that for 0, I would get 0.237. For 1, I would get 0.396. For 3, I would get 0.088. For 4, I would get 0.015. And for 5, I get 0.0009. Or if you want to say it's approximately 0.001. So I'm going to upload another calculator tips video for this specific one because there are definitely calculator functions that will make this a lot easier. It's called the binomial PDF function, and I'll be able to show you there what makes that easier about finding all of those. Okay, so for number 5, it says find and interpret the mean of the distribution. The mean of any binomial distribution is going to be the sum of all your, in this case, xi's times pi's. So if you remember that from earlier on, that would be 0 times 2.237 plus 1 times 0.396. So it follows that discrete distribution plus 0.264 times 2 plus all the way to 5 times 0.001, and that would get you 1.25. And your interpretation of this would be after many quizzes, the average number correct out of 5 questions is about 1.25. And find and interpret standard deviation. If you remember that formula, that would be the square root of all your xi's minus the mean squared times their probabilities. And then you would sum those all up. That would get you 0.968. And that interpretation would be the number correct out of 5 questions varies by 0.968 questions from the mean. There are ways that we can do this using a lot shorter methods because these are binomial distributions. So because of that, you can actually find that the mean would just be n times p, which n here is 5, p here is 0.25, 5 times 0.25 gets you 1.25. For the standard deviation, that's the square root of n times p times 1 minus p. So that would be, in this case, the square root of 5 times 0.25 times 0.75. And that would also get you 0.968. So that's what you have for you there. Now I'm gonna erase some of this so you can see it better because there's like a lot going on over here, just so you can see all this around number 7. What is the probability of getting at most 3 correct? So that's the probability at most 3. Remember, if x is less than or equal to 3. So less than or equal to 3 correct would be anything less than or equal to 3. So 0.088 plus 0.264 plus 0.396 plus 0.237. And that total equals 0.985. You could have also done it by subtracting off those other two if you prefer to do 1 minus those ones that I just underlined in orange, that's fine. So then what is the probability of getting 3 or more correct? So probability that x is greater than or equal to 3. So greater than or equal to 3 would be 0.088 plus 0.015 plus 0.001. So any of these, and that equals 0.104. So there are ways to do these quicker as well with a calculator function, and I'll go over those in a separate calculator video. But let's talk about your notes really quickly here. If you are talking about a binomial distribution, so I'm going to change this pen color, binomial. Remember, anytime we talk about distributions, we have shape, center, and spread. So shape, you can make a histogram of your values. center, which is the mean, which the mean is n times p. And spread, we have our standard deviation, which is the square root of n times p times 1 minus p. Interpretations, make sure you're talking about how many trials you have. Number of trials included, and context. So let's take a quick look down at what your check your understandings on today. You basically have to talk about if the distribution's binomial or not, make a histogram of that situation, calculate and interpret the mean and standard deviation. So in order to make that histogram, you need to kind of make a chart to determine what each of those values would be to make a histogram of that. And let me give you a little hint on that histogram. So if you were to make, this is about 10 multiple choice questions, so you just need to make a larger version of that. So your histogram, which on the x-axis would be number correct, and this would be the probability of getting them correct. So then you would have 1, 2, 3, 4, 5, all the way up to 10, and create that way. Remember, if you have any questions, you can come to office hours and check in that way.